Atomic bombs are among the most powerful and destructive weapons ever created, and understanding how they work requires delving into both the science and the history behind them. At the core of an atomic bomb is nuclear energy, which is derived from the nucleus of an atom. When we talk about nuclear fission, we're referring to the process where the nucleus of an atom splits into smaller parts, releasing a tremendous amount of energy in the process. To achieve this fission, we need a specific amount of fissile material. This is known as critical mass. When enough fissile material is brought together, it can initiate a chain reaction. This means that one fission event causes additional fission events, leading to an exponential release of energy. Imagine a row of dominoes falling. One pushes the next, and soon you have a cascade of destruction. There are two primary types of atomic bombs, the gun-type design and the implosion-type design. The gun-type bomb, like the one dropped on Hiroshima, uses a simple mechanism where two subcritical masses of uranium are brought together to form a supercritical mass. In contrast, the implosion-type bomb used in Nagasaki compresses a subcritical mass of plutonium into a supercritical state using conventional explosives. Both designs rely on the same fundamental principles of nuclear physics, but achieve their explosive power through different means. One of the most significant moments in nuclear history was the Trinity test in July 1945. This was the first ever detonation of a nuclear weapon conducted in the New Mexico desert. The explosion produced a blinding flash and a mushroom cloud that rose over 7 miles into the atmosphere. The power released was equivalent to about 20 kilotons of TNT, a staggering demonstration of the energy contained within atomic nuclei. The bombs dropped on Hiroshima and Nagasaki during World War II were pivotal in ending the war, but they also ushered in a new era of warfare and ethical dilemmas. The immediate destruction and loss of life were catastrophic, with hundreds of thousands of people affected by the blasts and the subsequent radiation exposure. This raises profound ethical questions. Is it ever justifiable to use such weapons? What are the long-term consequences for humanity and the planet? Modern atomic bombs are equipped with numerous safety mechanisms designed to prevent accidental detonation. These include features like arming codes, environmental sensors, and multiple fail-safes that ensure the bomb can only be detonated under specific conditions. Despite these advancements, the existence of nuclear weapons continues to pose a threat, not just in terms of potential use in conflict, but also through the risk of proliferation and terrorism. Understanding atomic bombs is not just about the science of nuclear reactions. It's also about grappling with the moral implications of their existence. As we advance technologically, we must also advance ethically, ensuring that the power we wield does not lead to our own destruction. The conversation around nuclear weapons is complex, and it's crucial that we engage with it thoughtfully, considering both the scientific marvel and the moral responsibility that comes with such power.